3. Statistical applications in environmental sciences. Module 7. Central tendency measure C. Learning objectives. Introduction. Positional averages. Relationship between mean, median and mode. Summary. Suggested readings 1. Learning objectives. In this module, a complete explanation about different types of positional averages of data will be discussed. This module helps us to learn different methods of central tendency measures and its properties. Through this module, one can learn about which method to use under what type of conditions. Questions with answers are included to give an in-depth knowledge of the topic. 2. Introduction. As we already discussed in the module, central tendency I, that data contain those elements that take different values for the same objective. In this scenario, the measure of central tendency is used to give you an idea about the data. Central tendency is a measure that provides a single value that represents a group of values. AM, GM and HM are discussed as a mathematical average methods. In this module, we will discuss another branch of central tendency measure that is positional averages. Positional averages are measures that provide values that depends on the requirement of the observers. For example, one is interested in the mid-value of the data for that median is used, other is interested in the value that repeat more in the dataset for that mode is calculated. We will discuss all these measure and other measures that lie in this categories. Some of them are quartiles, deciles and percentile. In the next section, we will start with the definition of median and we will see with examples how to calculate it for different dataset. After that we will discuss other positional average measure with their definitions and formula. Merits and demerits and relationship are also discussed between them for better understanding. 3. Positional average is median. Median is the most commonly used word in our practical life. Generally, one think of median as the value that split the item into two equal parts. In statistics, we also want to find out that value that lies in the middle of the data. To find out the median value, first arrange the observations in ascending or descending order, then take the middle value of the data. That value represents the median value. For example, if one has 11 observations in the dataset, then to find out the median, one has to arrange the observations in ascending and descending order, then take sixth value in the arranged series as median value. Now, if one has 12 observations in the datasets, then the method is different from the previous. 4. Statistical applications in environmental sciences. Method. As one can observe that the median lies between 6th and 7th value in the arranged data, so arithmetic average of these 6th and 7th observations are taken to find out the median value. The formula and methods to find out the median are given in steps. Basically, the calculation of median involve two things. A. To locate the position of middle value. B. To calculate its value. Based on the data type, median is evaluated as follows. A. Simple data. I first arrange the given observations x1, x2, xn in ascending or descending order. E. If n is an odd value, i.e. not divisible by 2, then the middle value is evaluated as n plus 1. 2. Th. Value in the data. E. If n is an even quantity, i.e. divisible by 2, then the median value is the arithmetic of n. 2. Th. And n. 2 plus 1 th value. Case 1. Find out the median of the following dataset. n 1 2 3 4 5 6 7 8 9 x 2 5 3 6 2 1 5 6 4. And here we add a new item in the data. N is an even value for finding out the median value. Again, arrange the observations in the ascending order. 21, 25, 36, 43, 49, 53, 56, 63, 67, 71. Here the median value lies between the 5th and 6th value in the ordered data set. After taking arithmetic mean AM of these two values, the median value is calculated as 51. B. Ungrouped frequency data. 5. Statistical applications in environmental sciences. If the data observations are available in the form of ungrouped frequency, the steps to find out the median are: I. Arrange the observations in increasing or decreasing orders. E. Compute cumulative frequency of the observations. E. Then use the formula n plus 1. 2. To calculate the middle value, where n is the total frequency. IV. After this, locate which cumulative frequency value is equal to n plus 1. 2 or just higher to it n. Corresponding value of observation is the median value. Case 3. Next, compute the cumulative frequency, CF, as shown in the third column of table 4, as n is 35, so using the formula n plus 1. 2 i.e. 36 halves is 18. In the third column, 76 observation has cumulative frequency equal to 18. So 76 is the median value of the dataset. Let us suppose the n is more than 35, i.e. 37, then using the formula n plus 1. 2 the value is 19, then the median value will be 89. Hence one can understand which value to choose for the median depending on the total frequency n. 6. Statistical applications in environmental sciences. C. Grouped frequency data. If the observations are given in the grouped frequency table, then one has to follow these steps to find out the median value. These are: I. First compute the value OFN. 2. E. Now use this formula. Median equals L1 plus N. 2 minus F. FXC. Where L1 is the lower class interval. N is the total frequency. F is the frequency value. C is the width of the class interval. F is the cumulative frequency preceding the class containing the value OFN. 2. One should refer to the module, Diagrammatic and Graphical Representation of the Data I, to recall the terms used above. And first find out the cumulative frequency of the observations as shown in the third column in table 6. Known. 2 is 20, which lies in the fourth row. 7. 40508. Median equals 30 plus. Table 6. Here L1 is 30, F is 10, F is 16 and C is 10. Now use the formula given above. Median equals 30 plus 20 minus 16. 6x10 equals 36.667, hence, one can evaluate the median for the group frequency data. Now, we'll discuss the merits and demerits of the median. Merits and demerits of the median. Every measure has some merits and some demerits. One should keep this in mind before applying the method on the data. Merits. The following are some of the important merits of median. Median is also a measure which is rigidly defined. One can understand this method easily. Even for a non-mathematical background person can understand this with little efforts. As median is considered as positional average of central tendency, so extreme observations have no impact on it. Also, one can find the median value for open-end class and unequal classes. Median can be calculated if extreme values are missing in the data set. The major advantage of this measure is that it can be located graphically and sometime even by inspection. It is considered as the best measure of central tendency in case of qualitative data. Although the qualitative data have no quantity but still can be arranged in increasing and decreasing order, for example, qualitative observations in terms of ranks can be ordered. Demerits. As comparative to other measure, median can be calculated if the observations are ranked either in increasing or decreasing order, which is not required in other measures of central tendency. Median does not take into account the magnitude of the observations. It only divides the whole dataset into two equal parts. As median is a positional average, so it is not treated for further algebraically purpose. 8. Statistical applications in environmental sciences. Median, like most of the measures of central tendency, may or may not be representative value of the series. It is not suitable where one has to assign weight to the observations, then median will not be used. Quantiles. As we discussed about median, which is a positional average that divide the data into two equal parts. There are some other measures that are also used to divide or partition the dataset into fixed number of parts. All these measures of such types are called quantiles. Some of them are quartiles, percentile, and deciles. Quartiles. Quartiles are those positional averages which divide the total number of observations into 4 equal parts. As we know that 3 points are required to divide the data into 4 equal parts. In quartiles, these 3 parts are called a first quartile, B, second quartile, C, third quartile. Percentile. Percentile are those positional averages that divide the data into 100 equal parts. Similarly as quartiles, they are termed as first, second, 99 percentile. Deciles. Deciles are those positional averages that divide the data into 10 equal parts, and they are also termed as first, second, ninth deciles. Now in the next section, we will discuss about the methods to calculate different positional averages in the given data set of different types. Methods to calculate positional averages. As median is also a positional average, there is a lot of similarities between the methods to calculate median and quantiles. One can observe this similarity from the formula given below, a simple series, let x1, x2, xn be the simple series and n denotes the number of observations. Then similarly for evaluating median, first order the observations in increasing and decreasing series. After that, the different type of quantiles can be found as follows. Quartile. First quartile is n plus 1. 4. Second quartile is 2n plus 1. 4 and third quartile is 3n plus 1. 4. As second quartile formula is same as median, so we can say that second quartile is also known as median. Similarly for percentile and decile, the methods are k the decile is n plus 1. 10, where k equals 1, 2, 9. 9. Statistical applications in environmental sciences. And mth percentile is n plus 1. 100, where m equals 1, 2, 99. Hence one can evaluate quantiles for simple data using the above methods and interpret them accordingly. B. Ungrouped frequency distribution, as the observations are available with frequency and the total frequency is termed as n. Quartile. Ith quartile is n plus 1, 4, where I equals 1, 2, 3. Similarly for percentile and decile, the methods are k the decile is n plus 1. 10, where k equals 1, 2, 9. And mth percentile is n plus 1. 100, where m equals 1, 2, 99. Hence one can evaluate the quantiles for ungrouped frequency data. C. Grouped frequency distribution. For evaluating quantiles for grouped frequency distribution, one must follow these steps. I. Divide total frequency, i.e. NQ, where Q can be 4, 10 and 100 for quartile, decile and percentile. E. Similarly as we did for median, locate the class interval whose cumulative frequency is equal to this ratio or just greater than this value. E. Select that class interval and use the formula given as Ith quartile equals L1 plus in 4 minus F. Fxc 1. Where I equals 1, 2, 3. Kth decile equals L1 plus Kn 10 minus F. Fxc 2. Where K equals 1, 2, 9. Mth percentile equals L1 plus Mn 100 minus F. Fxc 3. Where M equals 1, 2, 99. L1 is the lower class interval. N is the total frequency. F is the frequency value. C is the width of the class interval. F is the cumulative frequency preceding the class containing the value OFN. Q equals 4, 10 and 100. 10. Statistical applications in environmental sciences. Case 5. Calculate the first quartile, 9th decile and 50th percentile from the following data set of score obtained by 10 candidates out of 200 in state government examination. 78, 97, 112, 134, 100. Hands arrange the data in ascending order. It is evaluated as second. It is evaluated as second. Term plus 0.75, value of third term, value of second term, which is equal to 97 plus 0.75, 107 to 97 equals 104.5. Ninth decile value will be computed in the same manner and the value is 9, ninth term. Its value is ninth term plus 0.9, vol of 10th observation, value of ninth observations, which is equal to 152 plus 0.9, 165. 152 equals 163.7. 50th percentile is evaluated as 5.5, which is equal to median of the data. Hence it is the average of 5th and 6th term. So 50th percentile value will be 132 plus 134, 2 i.e. 133. Similarly, one can evaluate the value for other quantiles. Case 6. Calculate the first quartile, 9th decile and 50th percentile from the following data set of score. (11) Statistical applications in environmental sciences. Cumulative frequency is shown in third column in table 9. For first quartile, the formula ISN plus 1. 4 i.e. 100 plus 1. 4 equals 25. 25th term. It is evaluated from the cumulative frequency that contain the term or just than the term. So the first quartile value is 124. Ninth decile value will be computed in the same manner and it is 90. Ninth term. It can be seen from the table 9 that 166 values frequency hold the frequency of ninth decile. So the ninth decile is 166. Similarly, 50th percentile is evaluated as 50.5, which is equal to median of the data. Hence, by using the formula, the value of the median is 143. Hence, one can compute the positional average of different types for ungrouped frequency distribution. Case 7. Calculate the first quartile, 9th decile and 50th percentile from the following data set of score obtained by 500 students out of 200 in state government examination. (120) For first quartile, first computin. 4 i.e. 125th item and see where this value lies in the third column of table 11. Here the item lies in the class 100 to 120, then by using the formula given in equation 1, first quartile equals 100 plus 125 minus 30. 170 x 20 equals 111. Similarly, for ninth decile, the origin of the word mode is from a French letter la mode and its meaning is the most famous thing or thing that prevails as a trend in the society. In statistics, it is considered as a term that has highest frequency value in a series. In other words, mode is a value that occur with maximum frequency in a dataset. The mode of a distribution is the value at the point around which the items tend to the most heavily concentrated. It may be regarded as the most typical of a series of values, by Cowden and Croxton. Thus, it is clear from the definition that the mode is a value that has the greatest engrossment of values. One thing should keep in mind while evaluating in mind that the value that occurs a lot must be mode because it may be possible that the engrossment may be over some other value and also there may be 1 or 2 points where engrossment of value occur. Hence there is no single mode in a dataset. When 13. Statistical applications in environmental sciences. A data has single mode, it is called unimodal. When two mode, then it is called bimodal, and more than two, then multimodal. Mode has a great importance in the practical life, as every firm is interested to know the purchasing pattern of the customer, which brand and item customers use to buy more and at what price and quantity. For example, mobile company want to know the price at which customer used to buy handsets, the size of shoe, color and design that has maximum demand in the market. Hence, the importance of mode can be understood that it is measure that can be applied for quantitative data and qualitative data. Method to calculate mode. A simple series. It is very easy to determine the value of mode from a simple series. It can be determined by counting the value that has the maximum repetition in the data set. Hence the value that has maximum repetition is the modal value. Hands count the frequency of each observation. Here 34 occurs the maximum time, i.e. 5, and 43 occurs 2 times. Rest all the observations appear only 1 time in the series. Hence mode is 34. B. Ungrouped frequency distribution. Calculation of mode for ungrouped distribution is similar as simple series. The only difference is that here the observations are already given in the frequencies and there is no requirement to count them. So it is very easy to find mode in this case. C 1. Hence 50. Hence from the second column in table 12, one can see that frequency of 56 is the maximum among all the observations. Hence 56 is the mode. C. Grouped frequency distribution. In grouped frequency data, it is difficult to trace the mode value just by looking at the frequency of the observations. One must follow these steps to calculate mode. These are 14. Statistical applications in environmental sciences. I. First locate the interval that has highest frequency. E. Apply the formula. Mode equals L1 plus F1 minus F0. 2F1 minus F0 minus F2. XC4. Where L1 is the lower class interval that contain the largest frequency, F1 is the highest frequency in the dataset. F0 is the preceding frequency of largest frequency, i.e. F1. F2 is the succeeding frequency of the largest frequency, i.e. F1. C is the width of the class interval. One important thing, while applying this method, is that all the class intervals must be uniformly distributed, otherwise this method will not lead to correct result. Also, this method is not useful in case of multimodal data. Hands from table 13, one can see that the highest frequency is 45 and the corresponding class interval is 20 to 30. Now apply the formula given in equation 4. Mode equals 20 plus 45 minus 34. 90 minus 34 minus 21 x 10 equals 23.142. Hence the 23.142 is the mode of the dataset. Next we will discuss about the merits and demerits of mode. Merits and demerits. We will discuss about the merits of mode first and then demerits. Merits. Mode is the representative value of the observation, and the major benefit of this method is that mode can obtain just by looking at the dataset in simple and ungrouped dataset. 15. Statistical applications in environmental sciences. The second major benefit of using mode lies in the simplicity that is, it is very simple to calculate. Then other measures of central tendency. Mode has no effect of extreme observations. Mode can be evaluated for open-ended distributions. Mode can be calculated in case of missing observations. Mode can be used for qualitative dataset. Demerits. The major drawback of this measure is that it is not rigidly defined due to the application. Different formulae to compute mode, and all of them lead to different values. Mode value can only be used for further decision making if it is evaluated from a large dataset. For example, mobile companies and shoe companies must require large data set from a particular region to make their policies. One cannot rely on just few observations and change their policies. Another important thing about this measure that mode always does not exist. Unlike other measure of central tendency, it is not always possible to obtain mode from the dataset. Mode value cannot be used for further mathematical treatment. Mode cannot be determined in grouped frequency distribution like some other measures of central tendency. 4. Relationship between mean, median and mode. Now, we will discuss a little about the relationship between mean, median and mode. There is a relationship between mean, median and mode depending upon the symmetry of the data. If data are symmetric, then mean equals median equals mode. Otherwise, if data are not symmetric, i.e. asymmetric, then either mean greater than median greater than mode, or mode greater than median greater than mean. Hence, in literature another important exists between three measures. It is called an empirical relation between three measure. Mean minus mode. Mean minus mode equals 3, mean minus median. 5. Summary. In this module, measures of positional averages are discussed that is a branch of central tendency of measures. These are median, mode and quantiles. Although median is a part of quantiles, but it is studied differently from quantiles due to its importance in literature. In this module, we discussed about different positional averages and their methods and which method to use under which situations. We also discussed how to evaluate them for different types of data like simple, frequency data and group. 16. Statistical applications in environmental sciences. Frequency data. Merits and demerits of all three mean and relationship between them are also discussed for better understanding. Module 8. Measures of dispersion I. Learning objectives. Introduction. Summary. Suggested readings 1. Learning objectives. In this module, a complete introduction to measures of dispersion and different measures of dispersion are discussed with examples. Properties of different measures are also discussed with their merits and demerits. Through this module, one can easily understand about which method to use under what type of conditions. The topic of measures of dispersion is covered in 2 modules. This module will cover the absolute measures of dispersions. Other topic of relative measures will be covered in the module, measures of dispersion with skewness and kurtosis. Questions with answers are included to give an in-depth knowledge of the topic. 2. Introduction. In this module, an important measure that is used to see how each observation varies from the mean value. When one is interested to know about the variation of observations from the mean value, the measures that are used to detect this variations in the observation are called measures of dispersions. In the module, Central Tendency Measures I, and Central Tendency Measures II, we discussed about different measures of central tendency. We discussed about the mathematical averages and positional averages. The basic purpose of these measures is to find out a single value that represent the whole dataset. Also, concentration of observations about the central part of the data were observed. But these measure will not take into account of the fact that whether 2 or more different dataset have same mean values, but it does not mean that the observations are same. For example, we have 2 dataset given below that have same mean value, but the observations are not same. Dataset I, 8, 9, 10, 11, 13, 15. Dataset 2, 3, 4, 6, 14, 16, 23. Hence the total sum of both datasets are same, i.e. 66, and the mean is also same, i.e. 11. Now the question is how we can say that mean is the representation of the data. The answer is central tendency measure gives you just an idea about the concentration of the observation around a central value, but it does not say anything about the variation of these observations from the central part. In dataset I, the values are very close to each other and also to the mean value, so we can say that 11 is the correct representation of the dataset, but in dataset 2, observations are very scattered and also very far away from the mean value. Hence, one can see that 11 as a mean value is not represent the whole dataset in a correct manner. 4. Statistical applications in environmental sciences. Hence, one should not rely just on the central tendency measure to take any opinion about the observations, but also one should also think about the dispersion or variation among the observation. In this module, different type of measure will be discussed that consider variation of observation from different values like difference between highest and smallest values, absolute difference of observations from a particular quantity, etc. But mainly the variation of observations from its mean is considered the most in the literature. Definitions. Some authors have defined the measures of dispersion as: dispersion is the measure of variation of the items, by A. L. Bowley. Dispersion or spread is the degree of the scatter or the variation of the variable about a central value, by B. C. Brooks and W. F. L. Dix. In literature, the dispersion is also considered a synonym for heterogeneous in the data, as heterogeneous is basically used to understand the extent of variations among observations. Dispersion can only be zero if all the observations have same values. The dispersion is more when the difference between the observations is very large. So one can say that if the variation is small like in dataset I, then it is considered as insignificant, but if the variation is large as shown from the dataset 2, then it is considered as significant. Also, dispersion is termed as second-ordered means, as central tendency measures as the first-ordered means, where one can see the tendency of the values around the middle of the data. As measures of dispersion are basically used to discuss about the variation, scatterness of the observations from the central tendency measure. The measures of central tendency and measures of dispersion both together discuss about the characteristics of the dataset, but they do not able to demonstrate that, to what extent the observations deviate from the central value, i.e. whether equal number of observations are dispersed from the central tendency or whether the data is symmetrical about the mean or not. It also gives us an idea of how many observations have their value below the mean value or above the mean value. If one is interested to know about the concentration of the observations around a central tendency measure, then it is essential to study two more measures. These are skewness and kurtosis. These two measures are considered as a supportive measures for better understanding the characteristics of the data. Skewness and kurtosis is discussed in the module, Measure of Dispersion 2 with skewness and kurtosis. Importance of measures of dispersions. The main motive behind using these measures to check the authenticity of the central tendency measures. It is used to see whether the value of central tendency measure are reliable or not. B. The second important thing about the measures of central tendency is that these are also used to compare the two datasets through relative values. C. This measure is also useful in identifying the reasons behind the variations in order to control them, but these are not helpful in give the exact reason behind variations in the observations. 4. 5. Statistical applications in environmental sciences. Example, in electronic industry, quality of an item cannot be judged only by through whether an item is produced under defined limits, but also through the variations between the characteristics of observations. D. Measures of dispersions are also used to help for further analysis of the data like correlation, regression, testing of hypothesis and ANOVA, etc. As there are many measures of dispersion, the ideal measure prevails the following characteristics. The values of these measures should be rigid. B. It should be calculated on all the observations. C. The method should be easily calculated and understood by non-mathematical background person. D. The measure should be used for further algebraic treatment. E. The measure should not be affected by extreme values and fluctuation of the observations. The measures of dispersion are further categorized into two types. These are shown in the following flowchart. Figure 1. From the figure 1, the measure of dispersion is categorized into two measures, absolute measures and relative measures. As dispersion measure is used to detect the deviation of the observations from the central tendency. If the measures of dispersion express the dispersion of the observations in the original units, then the measures are called absolute measures of dispersion. One can only compare the variations between two series if both series are in same units, otherwise comparison is not meaningless. 2. Measure of dispersion. Absolute measures, relative measures. Range. Mean deviation or quartile deviation, standard deviation, coefficient of range. Coefficient of variation. Coefficient of mean deviation. 6. Statistical applications in environmental sciences. Overcome this problem. Those measures that give the dispersion values in terms of ratio and percentage are called relative measures. A relative measure of dispersion is the ratio of absolute measure of dispersion with its appropriate average. These measures are independent of units and these are termed as coefficient of dispersion. One important thing, while the calculation of relative measures, is that the units of absolute measure and the appropriate average must be same. In this module, absolute measures will be discussed with examples. Relative measures will be discussed in the module, Measures of Dispersion 2 with skewness and kurtosis. Range. Range is considered as the simplest absolute measure of dispersion. It is evaluated by just taking the difference between the maximum value and minimum value in the data set. Range equals maximum value, minimum value. Case 1. Range equals merits of range. These are the merits of the range measure. Range is the simplest among all the absolute measures of dispersion. Range is defined in a rigid manner and easily calculated. Due to this property, it is widely used in the industry as a quality control tool. Range is computed within second, hence one can get a complete picture of variability in the dataset in a short time. Demerits of range. There are few demerits of range also. These are as range is evaluated just from the difference of maximum and minimum value of the dataset. Hence it does not depend on all the observations. So it is possible that range will be same for two dataset that have same maximum and minimum value but different intermediate values that make no sense. As we already discussed that range depend on just two values and both of these values are extreme values. Hence range is affected a lot by extreme values. Also range will not take into account the shape of the distribution. It may be possible that range will be same for the dataset whether it is symmetric or skew-symmetric. 7. Statistical applications in environmental sciences. IV range is affected by the change in the observations. V range cannot be evaluated from the grouped frequency distribution with open-end class. Quartile deviation. This measure of dispersion is related with range and it removes the drawbacks of range up to some extent. It is defined as the difference between third quartile and first quartile divided by 2. In other words, quartile deviation equals Q3 minus Q12, where Q1 is the first quartile. Q3 is the third quartile. Also Q3 minus Q1 is known as the interquartile range. Case 2. Find out the quartile deviation from the following data set related to the marks obtained by 15 students in statistics. 60, 67, 56, 78. Hands arrange the observations in the ascending order. Now compute the first quartile plus 1. 4. Th term i.e. 55. Similarly third quartile is 12th term i.e. 78. Quartile deviation is 78 to 53, 2 equals 25 halves equals 12.5. Merits of quartile deviation. There are some merits of quartile deviation. These are: I. Quartile deviation is easy to understand like range. Is quartile deviation is based on first and third quarter, hence it removes the limitations of the range. Is quartile deviation consider only first quarter and third quarter value. These values are derived by neglecting first and last 25% of the observations respectively. Hence it is not affected by the extreme values. IV quartile deviation is more useful to consider in case of skewed symmetrical data. V quartile deviation can be evaluated for open-end class interval as it does not depend on the extreme values. Demerits of quartile deviation. There are some demerits of quartile deviation. These are: 8. Statistical applications in environmental sciences. I. Quartile deviation is evaluated on just half of the observations as it neglect first and last 25% of the observations. Hence it is not considered as a fully appropriate measure for detecting variation among observations. The quartile measure is based on quartiles which are positional averages. It represents the deviation of observations among quartiles, that is just a distance on a scale. The quartile deviation is very much influenced by the change in the observations. A change in single observations lead to change in the value of quartile deviation. IV quartile deviation just give an idea about the deviation like range. So it is not the best measure for measuring dispersion. Mean deviation. Mean deviation is computed as the absolute value of difference of observations from a central tendency, i.e. mean, median and mode. Mostly, mean deviation is calculated by taking deviation of observations from mean and median. Let x1, x2, xn be the n observations to compute mean deviation. First assume a number a and take absolute deviation of each observations from the value a, i.e. x1 minus a, x2 minus a, xn minus a. As some of the observations are more than a and some of them are less, so modulus is taken to accumulate the total deviation of observation from a point A. Now the sum of deviated observations from A is n array summation xi minus a, and the arithmetic mean of these observation will give mean deviation about A. Mean deviation about A equals 1. n array summation xi minus a. If A is chosen as mean value, then the deviation is called mean deviation about mean, and if A is chosen as median, then the deviation is called mean deviation about median. The above formula is used for simple series data. For ungrouped frequency distribution, the formula will be mean deviation about A equals 1. n array summation fi xi minus a. For grouped frequency distribution, the formula will be mean deviation about A equals 1. n array summation fi mi minus a, where n is the total frequency. Fi is the frequency corresponding to the ith observation, mi be the midpoint of the ith class interval. 9. Statistical applications in environmental sciences. Case 3. Hands first find out the am of the observations. It is 64. Now take absolute deviation of each observation from 64. The values are 34, 24, 14, 9, 4, 1, 6, 16, 26. Take the sum of these observation and divide it by 10, i.e. number of observations. The answer is 134 tenths equals 13.4. Now compute the AM. Now multiply this. The table 2. After that subtract this mean value. The values are shown in the table 2. After that subtract this mean value from each observation and take modulus. Now multiply this absolute value with the corresponding frequency. Now compute the AM of these absolute observation. Hence 8.22 is the mean deviation about mean. Observations frequency. Fi. Deviation from mean. Xi minus x. Absolute. Deviation about mean. Xi minus x Fi asterisk Xi minus x. Hands. First compute AM of the data using the formula n array summation Fi mi. N, where n equals n array summation Fi and mi is the midpoint of the ith class interval. The values are shown in the table 4. After that subtract this mean value from midpoints and take modulus. Now multiply this absolute value with the corresponding frequency. Now compute the AM of these absolute observation. Hence the mean deviation about mean for grouped frequency distribution dataset is 6.556. Class. Merits and demerits of mean deviation merits. There are some merits of mean deviation measure. These are: mean deviation is defined in a rigid manner. 11. Statistical applications in environmental sciences. Mean deviation is an easy method for a non-mathematical background person. Mean deviation is based on all the observations, so it is better than range and quartile. Deviation measures. Mean deviation is less influenced by the extreme values than range, standard deviation. Mean deviation is appropriate for comparison purpose because it is derived from the deviation of observations from central values, i.e. mean, median, or mode. Mean deviation is basically an average of absolute deviation from central value. Hence it remove biasness to some extent that occur due to observations while calculating and provide an accurate value for dispersion. Demerits. There are few demerits of mean deviation measure. These are: the major drawback of mean deviation measure is that while computing it we ignore the signs of deviation and take absolute of it. So one cannot get any information about the concentration of the observations above the mean or below the mean. So this measure is not useful for further mathematical treatment. Mean deviation cannot be computed for open-end classes distributions. Mean deviation is not an accurate measure of dispersion for highly skewed data. Although mean deviation has some limitations. Due to its simplicity and easy to understand features, it has great importance in accountancy, economics, forecasting, and business sectors. Standard deviation. Carl Pearson in 1823 first introduced this measure, and after that it is the most widely used measure of dispersion till date. Standard deviation is the measure that prevails all the features that other measures lack of. So basically it is considered as an ideal measure of deviation. It is also known as square root of variance, root mean square deviation, etc., and denoted by the Greek letter sigma, sigma. Standard deviation value is high or low when there is more or less variation among observations respectively. Let x1, x2, xn be the n observations and x be the average value, then the standard deviation SD is evaluated as SD equals square root n area summation xi minus x2n. For frequency data, the formula is SD equals square root n area summation fi xi minus x2n. For grouped frequency data, the formula is 12. Statistical applications in environmental sciences. SD equals square root n area summation fi mi minus x2n, where n is the total frequency. Fi is the frequency corresponding to the ith observation. Mi be the midpoint of the ith class interval. K6. Calculate standard deviation of the following dataset. 30. Ands. First calculate the mean of the observations, i.e. 64. Now subtract each value from 64 and take square. Add the square for all observation, i.e. 30 minus 64, 2 plus 40 minus 64, 2 plus 100 minus 64, 2, which is 4,290. Divide this sum by 10 and take a square root. Observations free. 3. Table 5. Ands. Calculate the mean of the observations as shown in Table 6. Subtract the mean from the observations as shown in 4th column. Now take square of these observations as shown in the 5th column in Table 6. Column 6 shows the product of frequencies with values from column 5. Now take sum of the observations. 13. Statistical applications in environmental sciences. Observations. Xi. Frequency. (14) Merits and demerits of standard deviation merits. As standard deviation is considered as the best absolute measure of dispersion. These are the merits of standard deviation measure. Standard deviation is rigidly defined measure. Standard deviation is based on all the observations. Standard deviation is evaluated by squaring of deviation of observations from the mean. This makes the standard deviation for further mathematical treatment. Standard deviation has less influenced by the change in the sample observations. It is also possible to compute the combined standard deviation of two or more dataset from individual standard deviation. Standard deviation is used for further statistical analysis like skewness and correlation. Demerits. Although standard deviation is considered as the best absolute measure of dispersion, but it is not free from demerits. These are: 15. Statistical applications in environmental sciences. Standard deviation is very difficult to understand for a non-mathematical background person. Standard deviation gives more weight to extreme values and less weight to values close to mean. As while squaring the deviation, this bias will be increased. Although standard deviation has some demerits or limitations, but this is the widely used method for the absolute measure of dispersion. 3. Summary. In this module, one category of measures of dispersion, i.e. absolute measures of dispersion, are In this module, one category of measures of dispersion, i.e. absolute measures of dispersion, are discussed in detail. These are range, quartile deviation, mean deviation, and standard deviation. We first give an introduction about these measures. Questions and answers are also included for better understanding of the topic. Merits and demerits of each measure are discussed for better understanding and comparison purpose. Other branch of dispersion measure that is relative measure of dispersion will be discussed in the module, measures of dispersion with skewness and kurtosis.